Hi everyone, welcome to the Automation in Autodesk Inventor webinar. The agenda for today, first of all, we're going to discuss who Baker Baynes is. Then I'm going to take you through what design automation is. We're going to look into practical applications of design automation. Parameters and equations, create and insert I features are two of the topics that I will discuss. And this is only a very small part of automation. It is just the beginning. And then in closing, we will discuss how we can help you. So we are running a campaign and walking you through the steps that you need to get to designing for the fourth industrial revolution. In the event we had a few months ago, we discussed the steps that we identified on how to get you to that step or to that place of the fourth industrial revolution. And we started off with the change from 2D to 3D design. So the second step is design automation. So this is the second webinar, and on popular demand, there might be more webinars on this topic because this actually makes the people's lives a lot easier. So please join us every month as we have these webinars and show you how you can get to design for the fourth industrial revolution. So hi, my name is Helandi Burger. I'm the Manufacturing and Process Plant Specialist at Baker Baynes. I've got a mechanical engineering diploma and over 10 years experience in a drawing office. I used to be a supervisor for a company that designed protection and automation panels for substations. And yeah, I enjoy playing music, especially bass guitar and drums. Just a little bit about myself. Okay, so Baker Baynes has evolved over the past 5 years from being an Autodesk reseller to a consulting company. And we set out to solve our customer problems through digital transformation. We help you to design and make a better world. In doing so, we offer various business process improvement consulting services, survey and design hardware and consulting, design software consulting, and we top it off with a blended learning approach to how we believe our customers can or should digest information. So I'm going to give you a poll question. I would like to know how familiar you are with Baker Baynes and our offerings. So, very familiar, somewhat familiar, or not familiar at all. I'm going to give about a minute for you guys to just answer the poll question, and then we'll carry on with the webinar. Okay, thanks for that. So design automation can mature from automatic basic parameters to full-scale product configuration. Your setup can be as simple or as complex as your current needs demand. So what is design automation? Design automation enables you to capture and reuse engineering knowledge and intent. Automation not only helps reduce errors and time spent on tedious, repetitive modeling tasks, but it can also be scaled to streamline downstream development processes. So with the fast pace of modern technologies, designers and engineers constantly have new software at their fingertips. It empowers them to enhance their approach to problem solving. But with this consistent flood of new tools, it's important to consider if the next big thing is critical to your workflow, or if you will simply be investing in another passing trend. However, Some solutions showcase such dramatic efficiency gains that there is no denying the benefits of their implementation. Design automation is one of them. Design automation is an approach that helps you capture and reuse engineering knowledge and intent. Automation technology enables you to easily utilize rule-based design without needing to know how to code. As a designer or engineer, do you find yourself spending excess time completing repetitive tasks, modeling standard features, or configuring products to custom specifications? Do you wish you could free up your time to focus on projects where you add unique value, innovating to create better products? Automation of your processes can help you advance projects to completion in mere seconds, which frees up valuable time for the tasks that require your level of skills and engineering knowledge. No matter the size of your company, or whether you are fabricating and manufacturing many different types of products or just a few, there are likely repeatable patterns and workflows in every design. Now that we spoke about the automation tools for design work, let's take it up a level. Inventor offers the ability to capture the engineering rules of your design so that you can reuse it to make new rapid configurations. How it works. Think about the last time that you reconfigured a standard model. How much time is spent on making changes to the design and all the manufacturing drawings that are sent to the shop floor. With automation, you can set rules that drive a custom product configurator right inside your CAD software and eliminate the rework that comes with repetitive tasks. First, build the logic that drives your configurator using the parameters you already captured when creating the 3D model of your design. Essentially, what you are doing is describing your design beyond the dimensions, constraints, and formulas you have in your model, and you are adding engineering rules so that changes to the design specification happen automatically. Some 3D CAD systems, including Inventor, include a library of code snippets, making it easier to define these rules. When your design intent is embedded into the 3D CAD model of your design, you can further improve the communication of your design intent by adding a form. A form is a dialog you can add to your design to help communicate which parameters can be edited and what the result should be. This embeds knowledge into the design, making it easier for users who are unfamiliar with the design to know what changes they can make, without inadvertently creating a design that falls outside of the design scope or that can't be manufactured. A junior designer or even a sales engineer can configure a design to customer requirements, safe in the knowledge that they can't make any mistakes, without taking up engineering time that can be better used on your ongoing projects. So we're going to look a little bit at the benefits of automation. And I've identified them as design more efficiently. So for instance, sheet metal parts and welding frames often include standard features that require simple yet tedious modeling. You can eliminate busy work by automating the creation of typical product features. Secondly, you can rapidly configure products to spec. So manually modifying models to meet customer specs can drain your engineering resources. So define parameters to create your 3D model and easily set rules that drive a custom product configurator. And thirdly, you can accelerate handoff to manufacturing. Extend automation beyond engineering with simple-to-code tools that capture and execute standard processes for the creation of drawings, toolpaths, and other documentation. So you don't want to spend time modeling standard components like nuts and bolts, and you don't have to. The Autodesk Inventor Content Center allows you to generate over 750,000 standard components, from fasteners to shaft components, and from rooted systems to structural steel. The Content Center libraries cover 18 international standards, including ISO, ANSI, and DIN. In addition to the standard components included, you can also publish your own parts and manage them with the Content Center. Let's see the Content Center in action. In this example, parts are inserted directly from the Content Center. Notice how the parts automatically size themselves to suit the features selected. Once inserted, Content Center parts can be resized or redefined from the library and contain all the information needed to automatically populate your bill of materials. Content Center supports Inventor Design Accelerators. It's a collection of rule-based design tools that allow you to quickly generate components around your functional requirements. Add fasteners or design a frame, power transmission or spring system directly from the Content Center components. There's no need to model any part yourself. In the Inventor Rooted Systems environment, Content Center provides components for your piping runs and cable harnesses. Design mechanical systems, which include flexible or rigid piping routes, using your existing geometry as a reference. Content Center supplies hoses, pipes, tubes, and industry standard pipe fittings, such as flanges and couplers. Design electromechanical systems, which are linked to your AutoCAD electrical schematics. Populate your design using the AutoCAD electrical data and Content Center linked libraries of components. You want to spend your time engineering and designing, not modeling. Autodesk Inventor's Content Center libraries save you time and effort, reduce modeling time, increase standardization, and make use of Inventor's design accelerators with Autodesk Inventor Content Center. Parameters and equations. So Inventor automatically defines model parameters in sketches, assembly constraints, and features. You can also define parameters for functional requirements. Parameters can define the size and shape of features and control the relative positions of components within assemblies. Features and sketches generate dimensions in a model. Each dimension has a unique dimension name. So the dimension name starts with the letter D, followed by a unique number, for example, D0 or D1. Relationships can be defined between these dimensions, enabling you to control a dimension value based on a function of another dimension's value. These relationships are called equations. Equations can also include user parameters. When one dimension is referencing another, the reference dimension in the equation is considered the driving dimension. The model in the figure shows a hole being located based on an equation. So if we look at the different dimension options that we can get, you will see that you get value. This displays the numeric values of the dimensions. Name. This displays the dimension names, for example, D4 or D5. Tolerance. This displays the tolerances defined on any dimensions. And the precise value. This displays the precise numeric values of the dimensions, not rounded. The precise value option also displays the actual value of a dimension if a tolerance is applied. For example, if the dimension is 2 plus minus 0.05 and is evaluated at the maximum tolerance value, the value is 2.050000000000. Okay, I'm going to show you a video of how you can add parameters to your models. In this example, I have a part open. I'm going to right click on extrusion and show dimensions. In display menu, I'm going to click on expression and it will show the values as you can see. I'm going to change the model parameters name to site 1 D1 I'm going to call side 2. D2 I'm going to call length. And D4 I'm going to call DIA, or diameter. Okay, side 2 I'm going to make equal to side 1. So in the equation I'm going to type side 1 and done. I'm going to right click on both dimensions and then you will see the changes that you've made in your expressions. Back in the parameters dialog box, I'm going to change the length in the equation column and say side 1 times 3. Okay, I'm going to edit the feature of the extrusion so that I can show you in distance A, it will now pick up that it's side 1 times 3, although the equation was changed in the parameters. Back at parameters, I'm going to add a numeric parameter, and it will add user parameters for me. Change the name to size, and I'm going to make the unit type unitless. Just click or type 1 and enter for the equation to pick up 1 unit. I'm going to add a comment, call it determine overall size. I'm going to add another parameter, user parameter. I'm going to call this round underscore 1. Keep this in millimeters. I'm going to change this one, the equation, to 3.175. And call this fillet radius. I'm going to select side 1, enter 25 millimeters times the size. The user-defined size parameter is going to drive the side 1 dimension. Since the size parameter is unitless, you must multiply it by a distance to obtain a distance value. I'm going to start and create a fillet. In the arrow drop-down list, I'm going to take list parameters. You will see round underscore 1 there at the top. I'm going to choose that to be the equation. Note that you cannot have any of the parameter names with a space in it, so you need to use underscore. Okay, I chose the 4 long sides and completed the fillet. So now I'm going to show you how the equation is going to drive this by changing the round 1 equation to 12.5. Make sure immediate update is ticked on. And the moment you enter, you will see that change. Then I'm going to change the equation of the size parameter to 2 units. And note how my feature updates. And done. Quick, easy, simple. Like I said, just the start of automation. Next up, we're going to look at creating and inserting of iFeatures. So Autodesk Inventor's iFeatures are a handy time-saving tool. It allows you to save a feature or a set of features, even a whole part, out to a separate file so that you can reuse them later. You can create an iFeature from an iPart or from a set of features that is useful for other designs. iFeatures are created from existing features or sketches. To make it easier to create the iFeature, we use parameters that have descriptive names and apply those parameters to items in the sketches and features that will become your iFeature. Creating an eye feature with default parameters, such as D0, can be confusing to identify. Okay, let's look at this next video. I'm going to open up a part. Okay, in the Manage panel, parameters, I'm going to update D1 to diameter and D2 to height. Note that you could also use the quick access toolbars to access the parameters. Plan your eye features so that a minimum number of parameters are required. If a dimension is always half of another dimension, use an equation rather than forcing you to enter both numbers. I'm going to change the equation for D0 to diameter divided by 3, and for D4 to diameter divided by 2. So now in the Manage panel, tab, the Author panel, I'm going to click on Extract Eye Feature. Select Extrusion 1 in the model browser. The selected features area displays Extrusion 1, Revolution 1, and the work features, because the other features are children. The renamed parameters are automatically entered in the Size Parameters area at the top. So note that the limits are set to none. We're going to change this, and I'm going to choose List for the diameter limits. I'm going to add a few values, 1.5875, 4.7625, 6.35, and 9.525. At the bottom, the default, I'm going to make 4.76. It's right in the middle. For height, I'm going to change this to range. The default is 10 millimeters. I'm going to make this, should be bigger than 2.5 and smaller than 25. Note that you have bigger as, bigger than equal, and bigger than equal to minus infinity, and the same for smaller as. So anything larger than 2.5 will be accepted, and smaller than 25 will be accepted. In the position geometry area, I'm going to change the prompt . Pick plane from base of locator. For base of locator. Going to right click on feature 1 at the top, rename, and I'm going to change it to boss. This name will be used to identify the eye feature in a model browser whenever it is placed. So once the eye feature is defined and its locating position is determined, it can be saved. By default, it is saved in the catalog folder. Alternatively, you can create a new folder in the catalog folder, or you can save the file to your workspace. So I already created a folder. I actually created the .ide file. So I am just going to replace it for now. I'm going to close. No need to save, as this is already saved now with my features. I would like to make a change to this .ide file. So I'm going to open up my custom eye features. And I want to add an object. Create from a file. I have a Word document that I would like to add here. So I'm searching for it. In my workspace, it's already saved there. And there we go. This file is a placement help file that can be added as a link or an embedded object. Embedded objects are not dependent on the external file, whereas linked files are dependent. So on the right, in the third-party node that was added now in your model browser, right-click on Embedding One and click on Placement Help. This time we need to save the eye feature as we've changed something to it. Now I'm going to open up a part where I would like to add this eye feature to. Going to insert an eye feature in the Manage tab, Insert panel. I'm going to browse and open locator.ide file. It's in my workspace. Note on the left side, the green symbol in the graphics on it says the next step is the position. This step enables you to select a face to locate the feature. Once you select the face, you can select the rotation or a position symbol to rotate or move the part. Alternatively, you can type the rotation angle in the fields. A check mark displays to the left of the name. And this means that it's fully defined. I'm going to change the size now. I'm going to use the biggest diameter we can. And to show you what happens, I'm going to make this 2.5 millimeters. And it gives you an error message. Now it already went to the next step. Note that it went back to 10 millimeters because that was the default. So you will have to go back and change it if you realized you made a mistake. I'm going to make it 8 millimeters and next. So down at the bottom, there's an eye icon for information. If you press it, it will open up that document that we have, the instructions for placement of the locator. So this is very important, where it gives you instructions for your whole team or anyone else that needs to use this eye feature to show them exactly what is needed for this locator to be placed in this model. So I'm going to activate the sketch. And now we need to move our eye feature. So there's no link between the IDE file and the eye features once it's placed. Therefore, the changes to the IDE file do not affect existing eye features. Even if you insert a revised eye feature into a file that contains an older version of the feature, the original eye feature is not affected. To update an existing eye feature, delete it and insert the new one. All right, so there we've added now our eye feature. I'm going to insert a new one. Yes, there is easier ways of getting that same one into all the other corners, but I would like to show you now just a few more times how this actually works and how nice it is to work with it. So I'm going to place it. The tick shows that everything is in place. Next up, I'm going to use my diameter, the smallest one this time. For height, 24.9. Next, and it is acceptable. Activate the sketch, and I'm going to place my eye feature. So you will also see at the bottom of your model browser that although you inserted the locator.ide eye feature, The eye feature is identified in the model browser as boss. And that's the name that we gave it when we created the eye feature. So we have on the left-hand side a boss 1 and a boss 2. And there you can see another one placed. Okay, just one more. Choose the face. I'm going to leave height at default. Next, activate sketch and finish. And there we go. So note that I did not do exactly as the document stated with all the constraints. I just used a very quick, simple way of adding the features to this part. It's just to show you guys how it actually works. But now you can see that you have indicated that this is it cannot be bigger than 9 point something. And it will then show you that they won't be clashes. You will see that there's no clashes because you've already predefined it. So none of the people that's actually working on this part, working with these features, will be able to choose anything else other than what you've set up for them to be used. And that makes it so nice and to work with and save a lot of time if everyone just uses the exact same feature. So, as discussed in the beginning of this webinar, it's part of a series where we are discussing the steps to follow to get you to Industry 4.0. So we are going to look into document management system and automation in the future, and we are also going to look into iLogic. That will also be very exciting. So please tune in next time, and hopefully you will learn some valuable insights on the iLogics. So let's say, for instance, you are a customer and you would love to automate, and you are just not sure, where you are in this whole system. Then, and you say, for instance, for me, yeah, we would love to automate, but we are only using 2D designs at the moment, and we don't have the software, for instance, like Inventor, to enable us to automate. So Baker Baynes sells Autodesk products. We can help you to decide what is the best fit for your organization. And if you're one of those customers that say, we are not sure if we can move to the next step in Industry 4.0 for automation, we can assess your business and create a tailor-made strategy to get you on your way there. So just as with software, we can assess as well and say, listen up, this is going to be the best product for your company, and or we can work out a strategy to see how we can get you to become a little bit more knowledgeable in automation. And then also you might be one of those customers that says our staff is not completely trained for this task. So if your guys, for instance, already have in fundamentals training or knowledge of Inventor, and you would like to give them that little bit extra to make them a little bit better, we can arrange for training on site and we customize it to your needs. And you give us an indication in our specialist series of what topics it is that you would like us to cover. So on all of those points, please get in touch with us. You can contact our sales team. You can contact basically anyone at our offices, and I will discuss now how you can get in touch with everyone. So with all of this now being explained and said, the last poll question for today, I would just like to know, are your company ready for automation? You can just answer for me, yes, we are ready and we know what to do. Yes, we are ready, but need training or guidance. No, we are not ready and need guidance on what to do next. I'm gonna give about 40 seconds. Thank you. Okay. I just quickly want to explain to you our iAdopt services. So iAdopt is our unique consulting methodology to help you as our clients. We can help you to develop and implement a digital strategy, and we can help you to transform and to get you to that Industry 4.0 design phase. We can help you to optimize your business processes and workflows. We can help you to adopt the new technology that's required to get to Industry 4.0, and we can help you to design and make a better world. So the benefits of this is that it focuses on solving the problem that you have at hand. We deliver tangible outcomes. We have a holistic organizational issue approach. We address all of your issues, and we go beyond the CAD environment. So it's not just for computer-aided drafting. This will go into document management systems and anything else that you need to get you up to that Industry 4.0 level. And this includes change management. So you can get in touch with us. This webinar will be online, and we will send it out to all of you guys, all of the customers, everyone that would like to see it. If you cannot follow the link or you have any problems to get into touch with us, let us know. The quickest way is to call us on 011 568 2060. But you can also follow us online on LinkedIn, Facebook, Twitter, Instagram, and YouTube. Our support desk are open from Monday to Friday, 8 till 11:30 at night. And you can email us at support@bakerbaynes.com or our normal landline of 011 568 2060. So this was a very, very exciting webinar for me. I really did enjoy creating my own content. If I knew how automation can make your life better and easier, and how all of this fits into, being more efficient, and how to, get you designing for Industry 4.0, I would have implemented this a long time ago when I used to work for the previous company. And like I said, we're very excited to bring you the next webinar and the next events. Please join us next month. This will broaden your outlook on automation and how you can get, once again, more efficient. And that's basically what it comes down to. Saving time, saving money. So we solve our customers' problems through digital transformation, helping you to design and make a better world.